Okay, so we're given the coordinates of two planes, ABC and ABD. And the coordinates are A, 220, 15 and 10, B, 270, 35 and 90, C, 260, 65 and 15, and D is 230, 60 and 70. So what I'm going to do is I'm going to start by drawing a horizontal line. And I'm going to start my measurements from this point right here. It's very important that we take all of our measurements from here. So the first point we have is A. I'm going to reduce this now and bring it up here. So my first measurement I have is A, and A is 220. So I'm going to measure over 220. And from that point, I'm going to draw a vertical line. And I'm going to measure up 15 and measure down 10. And that's point A. Very important that you index this question. You have to index this question. B, then we have 270. Excuse me. 270. And we have 35 up and 90 down. Then for C, we've got 260 across. $65 high, and we have 15 down, and finally we have D on 230. We're going to measure up 60 and down 75. That's my D point. Now, as you can see, we're told we have the plane ABC and ABD. So what I'm going to do is join them. So AB and then we have AB lovely. And now I'm going to darken in this portion of my XY line. I'm not going to darken in the rest, just a bit I leave. I'm not going to rub this out either. So that's my XY line. So if we look at our question, part 1, determine the dihedral angle between two planes. Now, as we know, these are two surfaces, or planes as we're calling them. I want to find the angle that's between them. So in order to do that, I need to look first and foremost at the line of intersection. So I'm going to get a colouring pencil, and my line of intersection here is AB. So I'm going to get AB. I'm just going to put this in colour to highlight. That is a common line when my two planes meet. In my plan, we're going to connect AB again. And yet again, that's my common line. Now, this line is not horizontal in my elevation or in my plan. This means that it is not a true length. So I need to make this line a true length. So what I'm going to do is I'm going to come out here to my bottom left. It doesn't have to be to the bottom left, but I am coming out to the bottom left because I have a bit of space here. And I'm going to come out and I'm going to draw an X1, Y1 line, and my X1, Y1 line is parallel to my line of intersection. Now this is very important. We have an elevation, a plan. This view here becomes an auxiliary plan. So this is an auxiliary elevation. So that's an auxiliary elevation. I'm now going to bring my 4 points out perpendicular. Now, very important, because this is an auxiliary elevation, I'm going to take my heights from my actual elevation. So using my compass, A, B, C, and D. Yet again, lads, like in the other views, it's absolutely vital that we label this so we know what we're looking at. So we're going to join A, B, then B plus T. Okay. Now, my line of intersection is still the line AB. However, if we look here, this line in my plan is parallel to my x1, y1 line. Because of that, I know that this line here is a true length, or TL. I would advise you to write that on your page because you're emphasizing everything that you know on your page. So we have a true length. The next thing I need to do is I need to make this true length a point view. In order to do that, I need to stand here and going in this way. So we're going to look along my line AB and we're going to extend the line AB. Then up here, now I could obviously go down below, but I'm going to go up. We're going to draw an X2, Y2 line. Now, this is an auxiliary elevation, so up here I'm going to have an auxiliary plan. I'm going to bring up my 4 points. Now, A and B are on the same line, so it's the equivalent to bringing up the two of them with one line. For my auxiliary plan, I'm going to get my distances from my X1, Y line back. That's very important. I'd take note of that on your page. So there's A and B, D, and, C. Now, I'm just going to join them together. Now, hopefully we've noticed, lads, that our true length line has become a dot. That's very important. The next thing that's going to be very important is this. My plane ABC has now become a line. We call this an edge view. So we have an edge view here. We also have the plane ABD is also an edge view, which is brilliant. They're asking us for the dihedral angle. So for the dihedral angle, I'm just going to get my compass and draw a little arc, put 2 little arrows on it for presentation wise. Get my protractor and measure my angle. And I'm getting an angle there of 75 degrees. Lovely. So that's part 1 of my question completed. I'm just going to zoom in then just a tiny bit. Okay. Next, I'm going to go back to my question. If I look at my question here, it's saying part 2, determine the projections of a perpendicular from D to the plane ABC. Now they mean perpendicular line, obviously, from the plane ABC. Now I have D here and I have the plane ABC. I can't draw a line perpendicular here because what do I go perpendicular to? Likewise, I can't do anything perpendicular here. I can't do anything here. But if I look up here, the plane ABC is an edge view, which essentially is a straight line. From point D, I can easily draw a line perpendicular to this edge view in order to get a point on a plane. So, using my sliding set squares, from D, I'm going to go perpendicular. I'm going to put this in colour to highlight it. And that point there now, I'm going to call it P. It doesn't matter what we call it. So there's my point P. Now, what I would like to do is I would like to find that point in all the different views. So what I'm going to do is I'm going to bring it back. And I'm going to bring it back at the same angle that I got my auxiliary plan for. So it's going to come back here parallel. Now, when I bring it back, you'll see that it's cutting the plane AC here, and it's cutting the line BC here. So I know that my point P is somewhere on that green line, but I'm not sure whereabouts it is. But I have a point here, and I have a point here. So what I'm going to do is I'm going to bring them back through the views. So I know yet again somewhere on that green line is going to be my point. Now, we can actually find it here because this is my auxiliary plan view. In order to get the distances for these points, I got my compass and I took the measurements from my X1, Y1 line back. So by the same logic, I can take the distance, which is P. If I draw a random line, so here on the side, and I'm going to take the distance from the X1 or X2, Y2 to P. I'm going to mark it off here, and that's the height of P. From this point, I'm going to draw a line which is parallel to my x1, y1 line. Because essentially what I'm saying is, from that point, the distance is parallel, so it's the same distance going across. Now, as you can see, it's cutting my line at such an angle that it's hard to distinguish the exact point. I'm making the point out to be that point there. So I'm going to join this back now to my point D. That's my point P. In order to find it in my auxiliary elevation, I'm going to just project it back. And in my elevation, I'm going to project it up. Now, I need to find the height of it in my elevation. I already have the height of it in my auxiliary elevation, so if I take this height and mark it off up here, that gives me point P. And that's going to join back to D. So that's my question completely finished.